Hello students, let us solve one more problem from JAM 2025 question paper. So here they given you a Maxwell relation and the equation of state, and they are asking to calculate delta CV by delta V with respect to temperature, and this coefficient is proportional to how it varies with the T we need to calculate. So first of all, we know that from first law of thermodynamics, dq is equal to du plus pdv. And now we also know dq I can write as a t ds du plus pdv. So my du becomes tds minus pdv. And now if I differentiate with respect to temperature, keeping the constant volume, if you keep volume constant, this term becomes 0, and this become your simply del S upon del T, del S upon del T, constant volume. And now we know this is CV. So my specific heat as constant volume is T del S by del TV. This is a known relation. So now we'll use this relation to find delta CV by delta V. So now I want to find delta CV by delta V, keeping the T constant. So this will be equal to, I'm keeping T constant. So this will be like this, del S. I want del upon del V, and inside you have del S upon del T, constant volume, and this is constant temperature. So this now further I can first differentiate with respect to T, keeping constant V, and then I can do it. I can reverse this order of differentiation. I can differentiate with respect to V first, keeping T constant. So I can write this one as, say, del by del T. Okay, and I'm differentiating del S upon del V, keeping temperature constant, and then del by del T, keeping volume constant, we can do later. So now this is your T del upon del T, del S upon del V at constant T is equal to del P upon del T, del P upon del T at constant V. So now this is also V, this is also V, so this become T del 2p upon del T square at constant volume. So now just you need to find this one. So you have already state equation P is equal to AT V square plus BT QV. Just differentiate with respect to temperature, keeping volume constant. This become AB square plus 3BT square, volume constant. And now del 2p upon del T square, keeping volume constant, this term becomes 0. This becomes 6BT upon V. And now just put the value here. So my delta CV is T del 2p upon del T square, keeping volume constant. And now this become T, this is 6B T upon V, and this quantity become T square. This proportional is, other things are constant. So this is proportional to delta CV upon delta V with respect to T is varies for constant volume also. It varies as a T square. So option A is the correct answer for this question. Hope you like the solution. Thank you very much.